All right, you're going to begin the lesson today by completing the third set of ACT Prep, 12 more questions. So beginning with question 25 and going through question 36, of 12 minutes to work. I'll have you pause the video while you work. Again, that's going to be in the description of the video. And then once you're finished, try to put yourself on a 12-minute timer. See if you can finish in 12 minutes. Once you're done, resume the video. All right, well, our gentlemen here are finished, so let's go and take a look at set 3 of the ACT Prep. Question number 1 says, what's the degree measure of the acute angle formed by the hands of a 12-hour clock, that means a normal clock, that reads exactly 1 o'clock? Well, 1 o'clock is going to look like this. But how would I figure the exact degree measure, Chris?
What you do is you know that to 3 o'clock is 90 degrees. So then you would divide that by 3 to get to 1.
All right, so
30 degrees.
30 degrees, 60 degrees, 90 degrees. That's one way to do it. The other way, you got a full 360 in the clock, but there's 12 numbers that go around. You could just take the 360 divided by 12, same answer, but the logic was impeccable. How many had letter B, 30 degrees? All right, good. Number 2. What's the probability that a number selected at random from the set 2, 3, 7, 12, 15, 22, 72, 108 will be divisible by both 2 and 3. Now, number 1 was really geometry, or number 25, excuse me, was geometry. But this next one, number 26, is just junior high-level math. What's the rule for divisibility by 2, class? The number must be even. And to be divisible by 3, now again, you could test these on your calculator, I guess. It would take longer. But the divisibility rule by 3 is that the sum of the digits has to be divisible by 3. So if it's odd, you already know it ain't going to work. But there are some even numbers that are divisible by 3. Which ones?
12, 72, and 108.
Good. All 3 of those. How many numbers in the set?
8.
So there's a 3 out of 8 probability. Again, that's junior high level work. How many had letter G?
Well, I had
1
I had looked only at the 2, and I left out the 3 on accident. So I had 5 eighths.
All right. Do we understand it now? And just pre-algebra. Number 3, another pre-algebra problem. A circle has a circumference of 16 pi feet. What's the radius of the circle in feet? Well, we have 2 different equations we can use for circumference. Again, going back to junior high, C equals 2 pi r, or you could say C equals pi d. But since it's asking about the radius, I think this is the easier equation to use, right? It tells me the circumference, C, is 16 pi feet. So C equals 2 pi r. How would I get the radius by itself, or solve for the radius, class?
Divide by 2 pi.
Divide away the 2 pi. And when I divide by 2 pi, I get 8 feet.
Did the pi's cancel?
They do.
I canceled the pi. I ended up canceling the pi's.
And 16 divided by 2 is 8. So 8, letter C, our answer. How do we do on that one? Excellent. Letter number 4 on mine. It's whatever number it is on yours.
28.
Let's go with 28. A rectangle with a perimeter of 30 centimeters is twice as long as it is wide. What's the area of the rectangle in square centimeters? This sounds a lot like geometry last year. You could start by drawing a little sketch, and it's twice as long as it is wide. A little bit of algebra here as well, though. I don't know the width of the rectangle, so maybe we just call it x. But I know it's twice as long as it is wide, so I could call the lengths
X plus 2. Or
2x. So therefore, I know that all the way around, x, 2x, x, 2x, class, total perimeter here is 6x. But I also know the perimeter is 30 centimeters. Therefore, what is x?
5 centimeters.
5 centimeters. So this is 5, and that means this is 10. And it asks, what is the area of the rectangle? Well, to find area, class, length times width, or base times height, I get 50 square centimeters, 4 centimeters squared. Letter G. Letter G, how'd we do? Good. Questions? Number 5 is a little bit of an algebra idea and a little bit of a geometry idea. We're on the xy coordinate plane, and it says we've got a line segment whose endpoints are at -3, 0, and at 7, 4. So 7, 4, -3, 0. There's the line segment. The question is, what are the coordinates of the midpoint? Now the geometry idea here is it's the point in the middle. So you kind of like look at it and be like, well, right about there looks like the middle, right? Well, what coordinates does that look like if these are 3's?
2, 2.
It looks like about 2, 2. Now there is a algebra 1 concept. We did talk about this in algebra 1 and algebra 2 though, where we said that midpoint can be found by adding the x values and dividing by 2, adding the y values and dividing by 2. That's the other way. Well, if you add the x's, class, you get
So 10, or 4.
4 divided by 2.
2.
You add the y's, you get
4.
divided by 2, you get 2. So here's the geometry idea, is just draw it and look at it, 2, 2. Or there's the algebra way, which is still 2, 2, so letter A. How many add letter A?
4.
Oh, Ethan.
I drew a picture, but I drew it.
How could 2, 4? It's not even on the line.
I had it. I had a little higher up. So
Oh, you had 4, 7, perhaps. Maybe that's what happened? Instead of 7, 4?
know. I got it wrong.
So if you're going to do the picture, I like the picture method because I think it's quicker as long as you're accurate. You got to be accurate with the picture. Number 6 is just annoying. Okay, it's not hard, it's just annoying. But we've got these points along a line, A, B, C, D, and it says B is between A and C, C is between B and D. In other words, they're in the order A, B, C, D. Okay? That's all it's saying. It's just a really long way of saying there's point A, then B, then C, then D. It says from A to B is 6 units. Then from B to C is twice as big. So obviously, class, 12 units. And then from C to D is twice the last distance.
24.
24. All right, then it says, what is the distance from the midpoint of BC
6.
to the midpoint of CD? Well, how big is this piece?
12.
12. How big is this piece?
6.
So how big is it between the midpoints? 18. And again, this to me is just the way you figure it out. You draw quick little segments on your paper and you're done.
That's what I did.
Okay? It's just annoying because it takes so long to read through it and make sure you digest it. I hate long worded problems.
It's easy.
It is, yeah, it is easy.
They're
It
long.
just, you only get a minute a question,
Yeah.
and it almost uses a whole minute on something that easy. It's frustrating. Let's see, number 7. This is a fun one. Which of the following statements must be true whenever n, a, b, and c are positive integers? In other words, there aren't zeros, there's no negative weirdness, it's just these are positive numbers. N is less than a, c is bigger than a, b is bigger than c. All right, now follow the conclusion here. C is bigger than a, b is bigger than c, n is even smaller than a. What's the biggest of all, class? B is the biggest of all. What's the smallest of all? N. All right, so B is enormous, N is tiny, C, and then A, okay? So keeping in mind which of these must be true. Could A be smaller than N? No, I know for sure it's not A because that directly contradicts the first given information. If I took B, which is big, and subtracted the smallest, and I took small and subtracted the smallest, would big minus smallest be bigger than small minus smallest?
No. Yes,
Yeah.
yes, it would.
So B sounds like it's true, but I'll be honest, I'm a little confused, so I'm reading the rest of them. Could B be smaller than N?
No.
No, we've established B is the biggest. Okay, if we took tiny plus biggest, would that equal second smallest plus second biggest? Maybe. But it says which of the following must be true. Does that have to be true? No. All right, what if I took twice the tiniest? Would that be bigger than the biggest and second smallest added together? That's impossible. So 3 of them are impossible. One of them doesn't have to be true, and it sure sounds like B has to be true. In fact, if equals, N and N, are subtracted from unequals, B and A, the results are unequal in the same order. B has to be true, and it is B. Okay, so, but that's kind of the thought process I go through. That one takes you a full minute, doesn't it? Right? But that took some thought, but that's geometry level thinking right there, isn't it? Did we get B as our answer?
I had D.
Okay, does it make sense now? D could be true, but it doesn't have to
I
be.
did all that. I was
B
like
has
so
to be.
confused there. I was like,
But do you see how to think it through? You got to kind of put them in order first. What's the biggest? What's the smallest? Kind of get the pecking order, if you will, and that's where it takes the time. That and really, again, on inequalities, I take the time to think through each one of them just to make sure I'm like, oh yeah, B could be true. But does it have to be? Is there another one? So I narrowed it down to B or D, and it's like, well, D doesn't have to be true. Yeah, duh. If equals are subtracted from unequals, results are unequal in the same order. B must be true. Let's go with B. All right, number 8. Jamal's high school grades by percentage of course credits in the graph. If A is worth 4 points, so yeah, this is like what we have, right? A is 4.0, B is 3.0, C is 2.0. What is his average, what is his cumulative GPA? Well, 70% A's, 20% B's, 10% C's. For his cumulative high school GPA, it's a 3.6 letter H. Did we get that? All right, so here we go. If 70% is A's, that's 0.7 times 4, and 20% B's, that's 3.0, and 10% C's, that's 2.0, we're going to have to add all the cumulative grade points together. And that's where we get the 3.6 from. Make sure that's all on camera, just made it good. Questions on that now? All right, number 9. What's the difference between 1.8 and 1.08 repeating? Well, I mean, you could try doing like fraction weirdness here, but literally, difference class means subtract. So I just went on my calculator, I did 1.8 minus 1.0808080808 until it wouldn't let me type any more digits, and it equals. And I got 0.71919192, but I know darn well that 2 is just a rounded up 1 because it had a 9 after it, right? So it's 0.7, and then 1 9s are going to repeat. So obviously, class, C is our answer. Again, just plug it in the calculator.
I had A because I had put the 1.08 repeating minus 1.8 instead.
Oh, okay.
So I did it backwards, and then I got
Something weird.
0.71 repeating.
Should we get negative 0.711111?
Well, yeah, the first time I did. This time I just got positive. I don't know how.
Okay. Number 10. This goes back to Algebra 1, showing relationships. Which of the following, actually, Algebra 2, we did this as well. Which of the following equations represents the linear relationship between time and velocity in the table? Then notice T is 0, then 1, then 2. Velocity is 120, then 152, then 184. Notice the velocity starts class at 120. And it goes up how much as the time increases? It goes up 32. So which equation shows the velocity going up by 32 for each unit of time, but starting at a constant 120? Letter G. Letter K also shows a 120 start, but it goes up 120 each time. That's not what's going on. So letter G. Questions on 10. How many had letter G? All right, questions? Number 11, industrial cleaners manufactured using only 3 secret ingredients, A, B, and C, which makes it sound super cool, which are mixed in ratio 2 to 3 to 5. Wait, we've been prepared for this. When we see in ratio 2 to 3 to 5, how do we represent them, class?
2x, 3x, 5x.
2x, 3x, 5x. So A, B, and C are 2x, 3x, 5x. And we mix all of them together. So we add them all together, and we get a mixture that is 42 pounds. Well, when you add them all together, you get 10x, and you divide by 10, the x is 4.2. But the problem says, how many pounds of secret ingredient B? Well, remember, B is the 3x, right? So 3 times 4.2 gives us 12.6, letter B. How many have B for your answer? Questions? How many have A, 4.2? You forgot to multiply the 3 back in? All right, questions? Does it make sense now? Okay, hopefully we weren't clueless. We've done a lot of those. And then number 12 on mine, it's number 36 on yours, I believe. This is just great intuitive thinking here with exponents.
He's happy.
I am. I love this one.
I'm sure Dexter's a happy boy.
Which means you should be very scared, right? Just kidding. No, you could be patting yourself on the back and you got this. All right, so we know that n is 8, and 16 times 2 to the m equals 4 to the n minus 8. But we know n, right? So plug in n. What is 8 minus 8?
0.
And anything with a 0 power equals?
0.
1.
Oh.
Oh, shame on you. Now look what you did. You made me start to write a 0. 1. Now, I'm trying to solve for the m. So I got to get rid of the thing that's least attached, which is the 16. So 2 to the m, how do I get rid of the 16? Divided away, 1/16. And here's the question. What exponent of 2 would give me 1/16? What exponent of 2 gives 16? 4. 2 to the 4th is 16. But this is the reciprocal of 16. What type of exponent means reciprocal? Negative. M is negative 4. So we have letter F. Anyone figure that out? Does it? You did.
I had 0.
Does it make sense now? You had 0.
I guess that's 0.
Oh, slob. All right, questions on this? Does it make sense
smarter
now?
than these people, yeah.
I tell you. All right, so out of 12, how'd you do?
Not very
I
good.
only missed 3.
Not very good.
Miss 3, Miss 3.
You only missed 3.
Yeah.
Ethan doubts you. All right, but it doesn't matter what Ethan thinks. Questions on this? All right.
He's mad because he missed 12.
Set those aside. Don't lose them. Set those aside, but don't lose them. Put them with your other ACT prep stuff so that you are keeping a collection of problems that you can go back and look over, a few days, maybe a week before the ACT. Now that you know what all the right answers are, you've seen them once, just kind of refresh your memory that this is how I approach this problem, this is how I approach this one, because you'll see similar types of problems. Not these same ones, but similar types of problems moving forward. Take your textbooks out now, if you would please, and turn to page 55. Page 55. And let's take a look at your homework. You had, I think, 7 problems to do on this page. Numbers 42, 44, 50, 52, 54, 58, and 60. Lots of trig ratios to identify. Good, 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 good. Good, 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 good. Good. All right. This is more neatly laid out than the rest of yours. I could tell at a glancing at it. Sorry. Yours was fairly neat, but
What about mine?
His is big.
Anyway, let's take a look at number 42. The first thing we need to identify is what quadrant we are in. Secant is negative, cosecant is positive. Class, it must be quadrant 2. Did we identify that?
Yes.
Good.
I did, but I didn't write it down.
Oh, we need to write that down. Then we see secant, which we know is,
Reciprocal of cosine.
so therefore it is
Or
hypotenuse over adjacent, right? So what is secant, class?
Hypotenuse over adjacent.
Okay, and the cosecant is
Opposite. Or opposite.
Adjacent over hypotenuse.
hypotenuse over opposite.
Folks,
We've been doing these the whole year
I just
now.
can't
It's
talk
week
today.
6. Anyway, so we know opposite, adjacent, hypotenuse, all of them. We know we're in quadrant 2. So for the sine, we should get a positive, 45 over 53. For the cosine, we should get negative 28 over 53. For the tangent, we should get negative 45 over 28. For the cotangent, we should get negative 28 over 45. How many did all 4 trig functions correct on 42? 44, what quadrant, since secant's positive but tangent's negative?
3.
Tangent negative in 3? Oh no, ASTC tangent would be positive in 3. It can't be 3. 4 is correct, because secant's positive, that's cosine's quadrant. But with the tangent negative, quadrant 4, which means only cosine will be positive. Everything else will end up being negative here. We're also given secant, class, which is
hypotenuse over adjacent.
hypotenuse over adjacent, and tangent, class, which is
Opposite over adjacent.
there we go. All right, so we know all 3 sides. We don't have to find anything. For the sine, we end up getting a negative 132 over 157. For the cosine, we get a positive 85 over 157. For the cotangent, negative 85 over 132. And for the cosecant, negative 157 over 132. Question?
No, I got it.
Okay, how many got number 44 correct? Any questions?
Please
All right.
take the quiz.
What?
Please take the quiz.
You'll find out. Let's see, number 50. Do you think, can we take the quiz or do we have a
Can we
quiz?
take it?
Oh, can you take it? Maybe a little bit. All right, number 50.
He's so fit, quiz.
Strategy tip. Just look at that given ratio for a second. Thoughts?
You can divide that.
I'd reduce it down first. And I get 12 to 13. I would. And then when I got the opposite, because you have adjacent hypotenuse, I'd get 5. But you could also just solve it as is straight up and get your opposite of 15. Right? You could do that as well. You also have to identify the quadrant. Cosecant's negative, less than 0. Cosine's positive, class, we must be in quadrant
3. No, 4.
4.
Oh, I get cosine.
Cosine's positive, ASTC, so we must be quadrant 4. So again, we have to reduce our answers down. But for the sine, maybe initially getting negative 15 over 39, but I'd say reduce it to negative 5 to 13. We're already given the cosine, so maybe we reduce that to 12 to 13. For the tangent, we get a negative 5 to 12. For the cotangent, negative 12 to 5. For the secant, a positive 13 to 12. And for the cosecant, a negative 13 to 5. How do we do on number 50?
I got them all right except for the reduction.
Did it reduce?
I reduced it now real quick.
Did it reduce?
Yeah, reduced.
Didn't reduce, but we got everything else. All right. Number 52. What quadrant?
2.
Quadrant 2. Good. Cosecant's positive, tangent's negative. That'll be quadrant 2. Also, we could reduce it. 25 to 7.
I actually reduced this.
You did reduce that one. Okay.
I just actually reducing this one.
Just reduced. Okay. What do we
No,
get
not
for
now. The last one I just reduced. Last night I reduced this.
Oh, okay. Good, good. What do we get for the adjacent?
48.
48, or if you reduced first, 24. So for the sine, you should have gotten a positive here in quadrant 2, 7 to 25. For the cosine, should have gotten a negative 24 to 25. For the tangent, should have gotten a positive 7 to 20, or negative 7 to 24. For the cotangent, a negative 24 to 7. For the secant, should have gotten a negative 25 to 24. And of course, we already have the cosecant. How do we do on 52?
Didn't reduce.
Didn't reduce.
Didn't reduce.
Didn't reduce. Reduce. Way to go, Ethan. Number 54. But you got 0 for the last answer on the ACT prep, so that's good. I just figured. Number 54. Once again, we could reduce.
Yeah, I reduced this one.
Oh, good, good. So you could have gotten a negative 17 to 8 to start out with, in which case your opposite would have been
8. No, I'm looking at the wrong one. 30.
Got down that.
well, initially 30. We reduced it down to 15 later, but yeah, initially 30 for the opposite. What quadrant, number 54? Oh. Cosecant's negative. It's less than 0. How could it possibly be quadrant 2?
So it's quadrant 3.
Quadrant 3. Secant's also negative, so it can't be quadrant 4. Anything negative means it can't be quadrant 1. That leaves negative quadrant 3. So, expecting tangent and cotangent to be your two positive functions. For the sine, should have gotten negative 15 over 17. For the cosine, negative 8 over 17. For the tangent, positive 15 over 8. For the cotangent, positive 8 over 15. Secant was already given to you. And then for the cosecant, should have had a negative 17 over 15. How do we do on number 54? Didn't reduce, didn't reduce, didn't reduce.
You can reduce.
I did reduce.
Questions?
No, how'd you reduce it? You can't
I
reduce.
reduced.
You can reduce. Divide everything by 2. That's what I was just saying at the beginning of the problem.
Maybe you should listen.
Anyway, let's take a look at number 58. This one's a little interesting.
What was the number one?
They tell us that theta is between negative 90 and 90. Where would negative 90 be? Show me with your hand. Negative 90. Down, right? This is negative 90 down here. Now you're starting at 0, going down to negative 90, but this is negative 90. Where's 90? Straight up. So going from negative 90, we're going to have to go this way to 90. What two quadrants does that give us?
1 and 4.
4 and 1, right? 1 and 4, quadrant 1. Not necessarily in that order, but that's the order the angle would travel. And we're told in number 58 that cosecant is positive. Which of these quadrants would cosecant be positive in?
1.
Only quadrant 1. So the nice thing is we don't have to worry about the SIGN. Everything's positive. This is great.
Why do you say SIGN?
Sine.
Because sine, S-I-N-E, and sine, S-I-G-N. Usually when I say sine, I'm talking about like sine, cosine, tangent. So I say S-I-G-N, so you know I'm talking about like the positive or negative. Just to
Can I
differentiate.
go take some medicine?
No. Well, we're going over homework right now. It's way too important. So we've got the cosecant, which is what over what class?
Cosecant is hypotenuse over
Opposite.
Hypotenuse over opposite. Look at you trying to come up with adjacent. And we need to find the adjacent, Quentin, to be 8. And so we get the the sine to be 15 to 17, the cosine to be 8 to 17, the tangent to be 15 to 8, the cotangent to be 8 to 15, and the secant to be 17 to 8. How do we do on number 58?
Pretty good.
Numero 60o.
54 and 58 are like the same thing.
Pretty much. All right, number 60. We're given that theta is between 0 and 3 pi over 2. Now, 3 pi over 2, what is that?
270.
Just 270. So from 0 to 270 is what quadrants?
1, 2, and 3.
Quadrants 1, 2, and 3. But we're told that what you call secant is positive. Which quadrant can secant be positive?
1 and 2. 1, 3. 4.
Only one. It's also positive in 4 along with cosine ASTC, but that wasn't an option. So quadrant 1. So once again, everybody's positive. It's happy. Secant, hypotenuse over adjacent. We're missing the opposite class, which is 72. Thank you, Quentin. And so we find the sine to be 72 over 97. We find the cosine to be 65 over 97. We find the tangent to be 72 over 65. The cotangent to be 65 over 72. And the cosecant to be 97 over 72. How do we do on number 60? Questions? Good. Let's go ahead and practice what we were looking at yesterday. Right at the end of the hour. I didn't give you any homework over this. But we were talking about reducing a function to the same function of a positive acute angle. And I said that this positive acute angle class is... This is what happens when I don't give you homework over this stuff. The positive acute angle that we were talking about is simply the reference angle, right? Or we call it rho. Okay, so basically we're just finding rho. For instance, if I gave you the cotangent of 574 degrees, we want to reduce this down to the same function of a positive acute angle. Well, remember, first of all, we said the angle got to not be ugly. And to not be ugly, the angle needs to be class between 0 and 360. It needs to be within that one initial revolution around the Cartesian plane. And this ain't it. So how do we do that? Just subtract 360. And we'll change this to make it look prettier. Cotangent of 214. Once it's between 0 and 360, now we can more easily tell which quadrant it's located in. What quadrant is 214? 3. It's bigger than 180, smaller than 270. Once we know the quadrant, we can more clearly think through what the reference angle would be. For 214, the reference angle is measured, remember, from the 180. How far from 180 is 214? 34 degrees. So once you know the reference angle and you know the quadrant, you can think through ASTC. Quadrant 3 cotangent is positive. We're going to keep the same function, but of the reference angle, 34 degrees. And I've simply rewritten it so instead of a big ugly, it's a nice, easy, acute angle. Get the pen out of your mouth. That's disgusting. Questions on this? All right. So let's take a look now, though. This was what we did yesterday. Don't be disgusting, Chris. This is what we did yesterday with degrees. But of course, degrees aren't the only units we can use for measuring angles, class. We could also use radians. Would you let Jamie in?
No.
We could use radians as well. Write this down in your notes. Perfect timing, Jamie. You'll want to go back, though, and watch the first 27 minutes of the video. And suppose we had sine of 2 pi over 3. And we wanted to convert this to the same function of a positive acute angle. Well, the first thing we want to do is make sure it lies not between 0 and 360, but between 0 and 2 pi. Is 2 pi over 3 between 0 and 2 pi? Yeah. And if you weren't sure, you think about what would this be with this denominator in terms of 2 pi? Well, it would be 6 pi over 3. Of course, 0 pi over 3 would be 0. Yes, 2 pi over 3 lies between 0 and 2 pi.
6 pi over 3?
You double the denominator, and this is 2 pi, because you cancel to get a 2. Alright, so this is 2 pi. Alright? The next thing you want to figure out, of course, is the quadrant. And this is where you want to use patterns, not actual converting into degrees and nonsense like this. We know on the Cartesian plane, pi is here, 2 pi is here. Practically speaking, if we had a denominator of 3, 2 pi would be 6 pi over 3. If we had a denominator of 3, what would plain old pi be? 3 pi over 3, right? Where is 2 pi over 3 in relation to 3 pi over 3 or 6 pi over 3? Quadrant 2. It's not even to 3 pi over 3 yet, is it? It's only made it 2/3 of the way to this full pi, correct? So again, you don't have to draw this, but mentally picture denominator 3. That's either 3 or 6. 3 pi over 3 is 1 pi. 6 pi over 3 is 2 pi. It falls in quadrant 2. So what's the reference angle going to be? Well, however far away from pi you are. But you've already thought in terms of 3 pi over 3. Don't make this hard, people. How far away from 3 pi over 3 is 2 pi over 3? 1 pi over 3. So the reference angle is pi over 3. So ASTC, sine in quadrant 2.
Equals,
Sine in quadrant 2, ASTC, positive. We're going to keep the same function and go with our reference angle, pi over 3. Make sure you have this down on your paper as well. Another one for you to get down as another example, the cotangent of 9 pi over 5. The first thing I like to do is mentally picture this because you can't see inside my brain. I'm going to draw it on the chalkboard. I've got pi, I've got 2 pi. If the denominator's 5, what's pi?
5 pi over 5.
What's 2 pi?
18 pi.
10 pi over 5. Where the numerator is twice as big as the denominator, so when you cancel, you get 2 pi. Does that make sense?
Yeah.
Where is 9 pi over 5, class, in relation to 5 pi over 5 and 10 pi over 5?
First quadrant.
Closer to 10 pi.
Almost to 10 pi over 5. It's 9 pi over 5. It's right there. It's knocking at the doorstep of 10 pi over 5. So obviously, class, we're in quadrant 4. How far in quadrant 4? Again, you measure always from the x-axis. If we were in the second quadrant, we'd see how far from 180, or pi. In the third quadrant, how far from 180 or pi. But we're in the fourth quadrant. How far from 360 or 2 pi?
1 pi over 5.
Pi over 5. So, reference angle, 1 pi over 5. Question for you. ASTC, quadrant 4, cotangent. Negative. We're going to keep the cotangent. We're going to keep the reference angle. We've rewritten it in terms of the reference angle. I feel like we need another one, so let's do another one. Write this one down, the cosine of 7 pi over 6. It's going to start clicking any minute now, I can tell. First thing I do is I get a little mental picture. Denominator 6, what's pi?
6
6 pi.
6 pi over 6. 6/6 of a pi is 1 pi. What would be 2 pi?
12 pi.
12/6 of a pi, right? 12 pi over 6. I told you it's going to click any minute now. Where is 7 pi over 6 in relation to those two angles?
Third close to
Ju-
this one.
Just past the 6/6, right? Because it's 7/6. So obviously then we're in quadrant 3. How far from pi, or 180, is it? 1 pi over 6. ASTC, cosine quadrant 3.
Cosine quadrant 3 is positive.
Negative. ASTC, so negative. Keep the cosine, keep the reference angle. And there we go. Starting to catch on to the pattern with radians. Again, you don't have nearly as much math to do. You're not subtracting 360. You're not subtracting 180. There's not the numbers you're working with the same way. You just have to be able to envision 1 and 2 in fractional form with a given denominator. And the rest of the math actually works out easier with radians than it does with degrees. Let's do a few more together, and then I'll have you try some on your own. But I feel like it's starting to click. I told you it's going to start clicking any second now. But let's mess you up here. Oh. Tangent of negative 13 pi over 9.
What?
Negative angle? That's not between 0 and 2 pi, is it? So, if it's not between 0 and 360, we add 360, right? If it's negative? Well, if it's negative, we don't add 360, we add 2 pi. How do I write 2 pi, though, with a denominator of 9? 18/9 of a pi is 2 pi. So just as we would add 360 to negative angles, in radians you add 2 pi, or 18 pi over 9 in this case. So that I can rewrite this as the tangent of
5 pi over 9.
5 pi over 9. Questions on that initial step? This is your first time seeing that. Questions? All right, now, quick sketch. In terms of denominator 9, what's pi?
9
9 pi over 9. What's 2 pi?
18 pi over 9.
18 pi over 9, which we actually just did that a second ago, right? Where's 5 pi over 9?
Before 9 pi over 9.
It's before, but it's way before. It's somewhere in this area.
But it's to the left of it because it's
Right, what's exactly half? Again, remember, this is pi over 2 up here. And sometimes you'll have to think of that. What would be half of 9?
4.5.
4.5 pi over 9, which would just be weird, right? It's just barely here in the second quadrant, isn't it? Make sense? But it is quadrant 2. So, in quadrant 2, the reference angle is measured from pi. How far from 9 pi over 9 is 5 pi over 9?
4 pi.
So the reference angle is 4 pi over 9. So, ASTC, quadrant 2, tangent is negative. We're going to keep the same function, and we're going to take the reference angle, 4 pi over 9. Make sure you have this one in your notes as well. And you're writing all of this down with me. Are we understanding the process here with radians? Because again, radians is just a different way of thinking. And again, the way I want you to think is patterns, not memorized math. That's just obnoxious. Okay?
He has flashbacks to college and he was going around in science class.
Apparently, all right. Actually, I wasn't thinking of that at all. Till just now. You give me ideas. All right, write this down. The cosecant of 19 pi over 6. I said he'll keep his mouth shut. No, he won't. Cosecant of 19 pi over 6. Again, the angle's got to be between 0 and 2 pi, right? So we draw our little sketch, and of course pi would be
6 pi.
6 pi over 6, and 2 pi would be 12 pi. Wait a second.
It's not.
This isn't between 0 and 2 pi. It's too big. If it was a big angle, like our 574 degrees, we subtract 360. But it's saying degrees. It's radians, so we don't subtract 360. We subtract 2 pi, and we get 7 pi over 6. Okay, now, where is that in relation to pi and 2 pi?
It's a little bit after 6 pi to 6.
A little bit after, so in quadrant 3. How far after 6 pi over 6 is 7 pi over 6? 1 pi over 6. ASTC, quadrant 3, cosecant?
Positive. No, negative.
ASTC, negative. Keep the cosecant, and pi over 6. Just about got it?
Yep.
Good, because you're going to have to do this for homework tonight. Secant of 3 pi over 4. Secant of 3 pi over 4. Draw a little sketchy thing. Pi.
4 pi over 4. No, that's not going to be right.
And 2 pi.
8 pi over 4.
8 pi over 4. Where's 3 pi over 4?
Well, first off, it's not going to go on the plane because it's
Sure it is.
1 pi, isn't it?
It just goes right here, which is in quadrant 2. And quadrant 2, you're trying to figure out the reference angle, right? How far from 4/4 pi is 3/4 pi? 1 pi 4 pi. So ASTC, quadrant 2, secant is negative. Keep the secant, keep the pi over 4. We're going to be able to do this tonight or over the weekend for homework. I recommend tonight, study hall, before you forget it all.
Yeah.
Or you can go back and watch the YouTube video. Jamie has to anyway. All right, at least the first 27 minutes. Questions on this? All right, homework for this evening. I wanted to give you some time to practice in class, but apparently we took too long going over the ACT. So we didn't have time for you to practice in class, which is a bummer. Homework for this evening is to do page 60, but I need you to turn your books to page 60 right now. Page 60, numbers 1 through 12 is the homework. But I'm going to reduce your homework because they wanted you to do all 6 trig functions for each of these, and I ain't going to do that to you. Kind of like here where I just give you one trig function for the angle. So I'm going to do this. Write these trig functions down for 1 through 12. Number 1, I want you to write tan. Number 2, CSC, cosecant. Number 3, sin. Okay, sine. Number 4, sine again. Number 5, secant. I hate that. Number 6, it's just Bama. That's it. Just Bama. Nobody else. Okay, Georgia. I'll give Georgia a little. They're doing low. No, not
They're doing it.
all right, number 6. They haven't played anybody yet. Cosine. They will play cosine.
They're going to
We'll
lose.
find out. Yeah,
They're going to lose.
They're not coming out of Happy Valley alive. Cosine for number 6. Cosine. Number 7, cotangent. Number 8, tangent. Number 9, cosecant. Number 10, sine. Remember, cosecant is CSC. They're on number 9. Number 10 is sine. Number 11, cosine. And number 12, secant. All right. We'll go. That's all. Doing all 12, but only one function for each, as opposed to all of them.
Page 61 through.
Page 60, numbers 1 through 12.
They're being evil.
All right. Have a wonderful rest of your day, and you are dismissed.